Hello and welcome to the Sleepy Physicist. I'm so glad you found your way here tonight. Maybe you're lying in bed, the lights dimmed, the world quiet around you. Maybe you're curled up in your favorite chair or listening as you drift off to sleep. Wherever you are, this space is for you, a gentle pocket of the night where wonder and calm can sit side by side. Tonight, I invite you to join me on a journey unlike any other. We're going to leave the Earth behind just for a little while. We're going to drift into the heart of our galaxy, the Milky Way, a river of stars, a spiral of mystery, a home to billions of worlds and secrets. Not in a rush, not in a textbook way, but as two friends might, gazing up at the stars and letting their thoughts drift outward, further and further, until the boundaries of the possible begin to blur. If you're already enjoying this quiet moment, I'd love it if you gave the video a gentle like or subscribe for more sleepy science stories. And if you're listening from somewhere special, a mountaintop, a little town, or just your favorite cozy spot, let me know in the comments. I love seeing the map of bedtime slowly light up. This video, like all others here, is for relaxation and education only. It's not a replacement for medical advice or professional sleep help, just a peaceful place to let your mind float. So now, let's begin. Lay back, take a slow breath, and imagine the night sky stretching out above you, vast, ancient, and full of questions. Some nights the sky feels close, like a blanket. Other nights it feels endless, a sea of darkness sprinkled with light. Tonight it is both, close enough to comfort, wide enough to inspire. Let's start with a simple act. Close your eyes if you like. Feel the weight of your body, the softness of your pillow or chair. Notice the gentle rhythm of your breath, in and out, slow and steady. With each breath, let the day's worries drift a little further away. Let your mind become light, unburdened, ready to wander. Now picture yourself standing outside, beneath the open sky. The air is cool, the world is quiet. Above you, the stars shine with a clarity you've never seen before. There are no city lights, no clouds, no distractions. Just the pure, ancient light of a billion suns. You tilt your head back, and for a moment, you feel very small. But it's not a frightening smallness. It's the kind that makes you feel connected to the earth beneath your feet, to the sky above, to the long, unbroken chain of people who have gazed up in wonder before you. And then, you see it, a pale milky band stretching across the sky. It's faint at first, almost like a cloud, but as your eyes adjust, it becomes clearer, a river of light flowing from horizon to horizon. This is the Milky Way, our galaxy, our home in the vastness of space. For thousands of years, people have looked up at this band of light and wondered what it was. Some saw it as a path for the gods, a bridge to the afterlife, a trail of spilled milk or the dust of creation. Others saw it as a mystery, a question, a promise of worlds beyond our own. Tonight, we're going to follow that river of stars. We're going to drift along its length, explore its hidden corners, and uncover some of the secrets it holds. We'll visit the crowded heart of the galaxy, where stars are packed so tightly that night never truly falls. We'll wander through the spiral arms where new stars are born in clouds of gas and dust. We'll peer into the dark, searching for black holes, neutron stars, and the invisible web of dark matter that holds it all together. But before we set off, let's take a moment to ground ourselves. Feel the support beneath you, the bed, the chair, the floor. Notice the gentle pull of gravity, holding you close to the earth. You are safe. You are at rest. The world can wait. With each breath, imagine yourself becoming lighter, as if the boundaries of your body are softening, dissolving into the night. You are not just a person in a room. You are a traveler, ready to journey beyond the familiar into the vastness of space. Let your mind drift upward, past the rooftops, past the trees, past the clouds. The air grows thin, the sky darkens, and soon you are floating above the earth, looking down at the blue and white marble spinning slowly below. You see the continents, the oceans, the swirling storms. You see the thin line of atmosphere, glowing faintly in the sunlight. You see the moon, pale and distant, circling its silent path. But you are not stopping here. You are going further, past the moon, past the planets, out into the deep dark where the sun is just a distant point of light. And then, you see it, the Milky Way, not as a band in the sky, but as a vast, spiraling disk of stars, gas, and dust. From this vantage point, you can see its true shape, a barred spiral, with arms that curl outward like the petals of a cosmic flower. At its center, a bright, mysterious bulge, glowing with the light of millions of stars. You realize that you are part of this galaxy, a tiny speck on a tiny planet, orbiting an ordinary star, one among hundreds of billions. And yet, you are not insignificant. You are a witness, a participant, a traveler in the grand story of the Milky Way. As you drift through the galaxy, you begin to sense its scale. The Milky Way is vast, 100,000 light-years across, 1,000 light-years thick, home to more than 200 billion stars. If you could travel at the speed of light, it would take you 100,000 years to cross from one side to the other. And yet from Earth, it appears as a thin band, a faint glow, a whisper of the immensity that surrounds us. You wonder about the stars you see. Some are close, just a few light-years away. Others are distant, their light traveling for thousands of years before reaching your eyes. Some are young and hot, burning with a blue-white fire. Others are old and red, nearing the end of their lives. Each one is a sun, a world, a story waiting to be told. You think about the planets that orbit these stars, worlds of ice and fire, gas and rock, some barren, some perhaps teeming with life. You imagine the civilizations that might exist out there, the dreams and questions that fill their nights. The stories they tell about the Milky Way. As you drift deeper into the galaxy, you begin to sense its mysteries. There are places where stars are born in clouds of gas and dust, places where stars die in explosions of unimaginable power. There are regions of darkness, where light cannot escape, and regions of brilliance, where stars are packed so tightly that they outshine the night. You realize that the Milky Way is not just a collection of stars, but a living, changing, evolving system. It is shaped by gravity, by time, by the invisible hand of dark matter. It is a place of creation and destruction, of order and chaos, of beauty and mystery. As you prepare to explore the hidden corners of the Milky Way, you feel a sense of wonder, a sense of connection, a sense of peace. You are a traveler on a journey through the galaxy, a witness to its secrets, a participant in its story. Take another breath. Feel the silence. Let your thoughts drift, slow and weightless, as we begin our journey into the Milky Way's hidden mysteries. As you float in the quiet dark, the Milky Way stretches before you, a spiral of light, a swirl of stars, a cosmic city that has been your home for all of your life and for all of humanity's history. But what is the Milky Way really? What does it mean to call this galaxy our home? Let's begin with the basics. The Milky Way is a galaxy, a vast collection of stars, gas, dust, and dark matter, all bound together by gravity. It is one of hundreds of billions of galaxies in the observable universe, but to us, it is special. It is the only galaxy we can see from the inside, the only one we can truly call our own. From Earth, the Milky Way appears as a pale milky band arching across the night sky. This band is the combined light of billions of distant stars, so far away and so numerous that their light blends together, forming a glowing river that has inspired myths and stories for millennia. The name Milky Way comes from the ancient Greeks, who imagined it as a stream of milk spilled across the heavens by the goddess Hera. In other cultures, it is a path of souls, a celestial river, a backbone of night. But the Milky Way is more than just a band of light. It is a structure, a system, a living galaxy with a history and a future. It is a barred spiral galaxy with a central bulge of stars and a long, thin bar stretching across its heart. From this bar, spiral arms curl outward, winding through the disk like the arms of a cosmic whirlpool. These arms are not solid. They are regions where stars are born, where gas and dust are compressed by waves of gravity, igniting new suns in brilliant clusters. The Milky Way is enormous. It spans about 100,000 light-years from edge to edge and is about 1,000 light-years thick in its disk. If you could travel at the speed of light, it would take you 100,000 years to cross from one side to the other. And yet, compared to the vastness of the universe, the Milky Way is just a small, ordinary galaxy, one among many, but precious to us. Our solar system is located about 27,000 light-years from the galactic center, in a quiet suburb known as the Orion Arm. Here, the stars are spaced far apart, and the night sky is dark enough to see the Milky Way's glow. But if you could travel to the center of the galaxy, you would find a very different world, a crowded, bustling region where stars are packed so tightly that night never truly falls. The Milky Way is home to more than 200 billion stars, and perhaps as many as 400 billion. Each star is a sun, a world, a story waiting to be told. Some are young and hot, burning with a blue-white fire. Others are old and red, nearing the end of their lives. Some are alone, drifting through the galaxy in solitude. Others are part of clusters, families of stars born together from the same cloud of gas. But stars are not the only inhabitants of the Milky Way. There are planets, billions of them, orbiting their suns in endless variety. Some are gas giants like Jupiter and Saturn. Others are rocky like Earth and Mars. Some are frozen, some are scorched, some are shrouded in clouds or rings or storms. And among these planets there may be life, simple or complex, familiar or strange, waiting to be discovered. There are also clouds of gas and dust, vast dark regions where new stars are born. These clouds are the nurseries of the galaxy, places of creation and transformation. They are cold and dense, hiding their secrets from view. But when a star is born, it lights up the cloud, carving out bubbles and pillars, sending shockwaves through the gas. And then there are the mysteries, the things we cannot see, but know must be there. The Milky Way is surrounded by a halo of dark matter, an invisible substance that outweighs all the stars and gas combined. We do not know what dark matter is, but we can see its effects. It holds the galaxy together, shapes its rotation, and binds it to its neighbors. There are also black holes, regions where gravity is so strong that nothing, not even light, can escape. The Milky Way's center is home to a supermassive black hole, millions of times the mass of the Sun. Around it, stars whirl in dizzying orbits, and clouds of gas spiral inward, vanishing into the darkness. The Milky Way is not alone in space. It is part of a small group of galaxies known as the Local Group, which includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies. These galaxies dance around each other, pulled by gravity, sometimes merging, sometimes passing by in silent encounters. Our galaxy is also moving, spinning around its center at hundreds of kilometers per second, orbiting the Local Group, and drifting through the universe as part of the larger Virgo supercluster. Everything is in motion, everything is changing, everything is connected. As you float in the quiet dark, you begin to sense the scale of it all. The Milky Way is vast, ancient, and full of secrets. It is a place of birth and death, of order and chaos, of beauty and mystery. It is our home, our cradle, our window into the universe. You realize that you are part of this galaxy, a tiny speck on a tiny planet, orbiting an ordinary star, one among hundreds of billions, and yet you are not insignificant. You are a witness, a participant, a traveler in the grand story of the Milky Way. You think about the journey your atoms have made, born in the heart of a star, scattered by a supernova, gathered into clouds, woven into planets, and now, for a brief moment, part of a living, thinking being. You are the universe becoming aware of itself, looking back at its own history, dreaming of its own future. As you prepare to explore the hidden corners of the Milky Way, you feel a sense of wonder, a sense of connection, a sense of peace. You are a traveler on a journey through the galaxy, a witness to its secrets, a participant in its story. Take another breath. Let the silence of the galaxy fill you. Let the ancient light of the stars remind you that you are part of something vast and beautiful. You are a traveler in the Milky Way, our galactic home. As you float in the gentle dark, the Milky Way stretches before you, a spiral of light, a river of stars winding through the night. But what is the true shape of our galaxy? What lies hidden in its arms, its heart, its mysterious outskirts? Let's drift together through the structure of the Milky Way, exploring its form, its features, and the secrets it holds. Imagine for a moment that you could step outside the galaxy and look back from afar. The Milky Way would appear as a grand, barred spiral, its disk thin and wide, its arms curling outward in elegant sweeps. At the very center, a bright, bulging core glows with the light of millions of stars, while a long, slender bar of stars stretches across the heart of the galaxy. From this bar, four main spiral arms unfurl, winding through the disk like the arms of a cosmic pinwheel. The disk itself is vast, about 100,000 light-years across, but only about 1,000 light-years thick. It is in this thin, spinning disk that most of the galaxy's stars, gas, and dust reside. The disk is not flat and smooth, but rippled and warped. shaped by the gravity of neighboring galaxies and the motions of stars within. Within the disk, the spiral arms are regions of higher density, waves of gravity that compress gas and dust, triggering the birth of new stars. These arms are not solid structures, but moving patterns, like traffic jams in the flow of stars. As gas clouds enter an arm, they are squeezed, igniting bursts of star formation. Young, hot stars light up the arms, making them shine bright against the darker background. Between the arms, the disk is quieter, filled with older stars and less gas. Here the night is darker, the stars more scattered, the pace of creation slower. But even in these quieter regions, the galaxy is alive with motion. Stars orbiting the center, clouds drifting, planets spinning in their endless dance. At the very center of the Milky Way lies the galactic bulge, a dense, spherical region packed with stars, gas, and dust. The bulge is home to some of the oldest stars in the galaxy, as well as the mysterious supermassive black hole known as Sagittarius A. The bulge is not perfectly round, but elongated, shaped by the bar of stars that runs through its heart. Surrounding the disk and bulge is the galactic halo, a vast, diffuse sphere of old stars, globular clusters, and dark matter. The halo extends far beyond the visible edge of the disk, reaching out for hundreds of thousands of light years. The stars in the halo are ancient, their orbits tilted and elongated, moving through the galaxy like ghosts from a forgotten era. Within the halo, globular clusters shine like cosmic lanterns, tight balls of hundreds of thousands of stars, bound together by gravity. These clusters are among the oldest objects in the galaxy, relics from its earliest days. They orbit the center of the Milky Way in great looping paths, passing through the disk and out into the dark. The Milky Way is not a static structure, but a living, changing system. The spiral arms wind and unwind. The bar rotates, the disk ripples and warps. Stars are born, live and die, their ashes scattered to seed new generations. Gas clouds drift, collide, and collapse, lighting up the galaxy with bursts of creation. Our solar system is located in a quiet region between two spiral arms, the Sagittarius arm and the Perseus arm, in a smaller spur known as the Orion arm. Here, the stars are spaced far apart, and the night sky is dark enough to see the Milky Way's glow. But if you could travel to the center of the galaxy, you would find a very different world, a crowded, bustling region where stars are packed so tightly that night never truly falls. The structure of the Milky Way is shaped by gravity, by time, by the invisible hand of dark matter. The galaxy spins, its stars orbiting the center at hundreds of kilometers per second. The spiral arms are not fixed but move through the disk like waves in a pond. The bar at the center rotates, stirring the stars and gas, shaping the flow of matter. But the Milky Way is not alone. It is surrounded by dozens of smaller galaxies, dwarf companions that orbit the main disk, some merging, some being torn apart by gravity. These interactions shape the structure of the galaxy, warping the disk, triggering waves of star formation, and adding new stars to the halo. As you drift through the Milky Way, you begin to sense its complexity. It is not just a flat disk of stars, but a layered, textured, dynamic system. It is a place of order and chaos, of creation and destruction, of beauty and mystery. You realize that the Milky Way is not just a collection of stars, but a living, changing, evolving galaxy. It is shaped by gravity, by time, by the invisible hand of dark matter. It is a place of creation and destruction, of order and chaos, of beauty and mystery. You are a traveler in this grand structure, a witness to its secrets, a participant in its story. You are part of the river of stars, drifting through the galaxy, carried by the currents of gravity and time. Take another breath. Let the structure of the Milky Way fill you with wonder. Let the ancient light of the stars remind you that you are part of something vast and beautiful. You are a traveler in the Milky Way, a river of stars winding through the night. As you drift through the Milky Way, you begin to sense that not all stars live forever. Some shine for billions of years, quietly burning their fuel, while others live fast and die young, ending their lives in spectacular explosions. But what happens after a star dies? What remains in the darkness hidden among the stars? Tonight, let's explore the galaxy's most mysterious remnants: black holes, neutron stars, and the silent corpses of suns. Imagine for a moment the life of a massive star. It is born in a cloud of gas and dust, ignites with a brilliant blue-white light, and spends millions of years fusing hydrogen into helium, then heavier elements, in its core. But eventually, the fuel runs out. The balance between gravity and pressure breaks. The core collapses, and the outer layers are blown away in a supernova, a cosmic explosion that can outshine an entire galaxy for a brief moment. What is left behind depends on the mass of the star. If the core is heavy enough, gravity crushes it into a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. Neutron stars are only about 20 kilometers across, but they contain more mass than the Sun. Their surfaces are smooth and hard, their gravity immense, their magnetic fields among the strongest in the universe. Some neutron stars spin rapidly, sending beams of radio waves sweeping through space. These are pulsars, cosmic lighthouses that flash on and off as they rotate. The first pulsar was discovered in 1967. Its regular pulses so precise that astronomers briefly wondered if they had found a signal from an alien civilization. Since then, thousands of pulsars have been found, each one a ticking clock in the galaxy, marking the passage of time with every spin. Other neutron stars are even stranger. Magnetars have magnetic fields 1,000 times stronger than ordinary neutron stars. When their fields twist and snap, they release bursts of X-rays and gamma rays, lighting up the galaxy with brief, powerful flares. These events are rare and mysterious, their origins still not fully understood. But if the core of the dying star is even heavier, gravity wins completely. The core collapses into a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. The boundary of a black hole is called the event horizon. Once something crosses this line, it is lost forever, swallowed by the darkness. Black holes come in many sizes. Some are just a few times the mass of the Sun, stellar mass black holes formed from the deaths of massive stars. Others are millions or billions of times more massive, supermassive black holes found at the centers of galaxies, including our own Milky Way. There may also be intermediate mass black holes, lurking in star clusters or the outskirts of galaxies, but these are harder to find. Black holes are invisible, but their presence can be detected by the way they affect their surroundings. When a black hole pulls in gas from a companion star, the gas spirals inward, heating up and emitting X-rays before vanishing into the darkness. Some black holes are found by watching stars orbit an invisible companion, their motions betraying the presence of a massive, unseen object. The most famous black hole in our galaxy is Sagittarius A, the supermassive black hole at the center of the Milky Way. It is more than 4 million times the mass of the Sun, but its event horizon is smaller than the orbit of Mercury. Around it, stars whirl in dizzying orbits, and clouds of gas spiral inward, vanishing into the darkness. But not all stellar corpses are so dramatic. Stars like our Sun end their lives more quietly, shedding their outer layers to form beautiful planetary nebulae, glowing shells of gas that expand into space, lit by the dying core at the center. This core becomes a white dwarf, a hot, dense remnant about the size of Earth, slowly cooling and fading over billions of years. White dwarfs are common in the galaxy, the silent embers of stars that once shone bright. Some are found in binary systems, where they can steal material from a companion star. If enough material accumulates, the white dwarf can explode in a Type Ia supernova, a brilliant flash that briefly rivals the brightness of an entire galaxy. As you drift through the Milky Way, you realize that the galaxy is filled with the remnants of dead stars. Some are visible, pulsars flashing, planetary nebulae glowing, supernova remnants expanding through space. Others are hidden, black holes lurking in the dark, white dwarfs cooling in silence, neutron stars spinning unseen. These stellar corpses are not just the end of a story, they are the beginning of new ones. The material ejected by dying stars enriches the galaxy with heavy elements: carbon, oxygen, iron, gold. These elements are the building blocks of planets, moons, and life itself. Every atom in your body heavier than hydrogen was forged in the heart of a star, scattered by a supernova, gathered into clouds, and woven into new worlds. You realize that you are connected to the life and death of stars. You are made of stardust, a product of the galaxy's endless cycle of creation and destruction. The black holes, neutron stars, and white dwarfs are your ancestors, your companions, your future. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of awe, a sense of humility, a sense of belonging. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and frontier. Take another breath. Let the silence of the stellar corpses fill you with wonder. Let the darkness remind you that every ending is a beginning, every death a prelude to creation. You are a traveler in the Milky Way, drifting among the remnants of stars, seeking the secrets of the galaxy's hidden hearts. As you continue your journey through the Milky Way, you begin to notice that not all is light and brilliance. There are places where the stars seem to vanish, where the spiral arms are interrupted by shadows, where the galaxy's glow is dimmed by something unseen. These are the regions of cosmic dust and dark clouds, the veils of mystery that both hide and reveal the secrets of our galaxy. Imagine drifting into one of these dark clouds, leaving behind the bright clusters and glowing nebulae. The starlight fades, replaced by a deep, gentle darkness. The temperature drops, the silence deepens, and you find yourself surrounded by a world of shadows. This is not emptiness, but fullness, a place where matter gathers, where the seeds of stars and planets are sown. Cosmic dust is made of tiny grains, microscopic particles of carbon, silicon, ice, and metals. Each grain is smaller than a speck of smoke, but together, they form vast clouds that stretch for light years across the galaxy. These dust grains are forged in the atmospheres of dying stars, blown into space by stellar winds and scattered by supernovae. Over millions of years, they drift through the galaxy, joining with gas to form the dark clouds that shape the Milky Way's structure. These clouds are called molecular clouds or dark nebulae. They are the coldest, densest regions of the galaxy, with temperatures just a few degrees above absolute zero. Inside, the gas and dust are so thick that visible light cannot pass through. From Earth, these clouds appear as dark patches against the brighter background of the Milky Way, a cosmic silhouette, a shadow on the face of the galaxy. But the darkness is not empty. Inside these clouds, chemistry is at work. Atoms of hydrogen and oxygen combine to form water. Carbon and nitrogen join to make complex organic molecules. Ices coat the dust grains, creating tiny laboratories where the building blocks of life are assembled. Some scientists believe that the molecules formed in these clouds may have seeded the early Earth, bringing the ingredients for life to our planet. The dark clouds are also the birthplaces of stars. As gravity pulls the gas and dust together, the cloud fragments into dense clumps. Inside each clump, the pressure and temperature rise until nuclear fusion ignites, and a new star is born. The energy from the young star heats the surrounding dust, causing it to glow in the infrared. Jets of material shoot out, carving holes in the cloud, lighting up the gas in brilliant colors. But from the outside, the cloud remains dark, its secrets hidden from view. Only with special telescopes, infrared, radio, and millimeter wave, can astronomers peer inside, mapping the structure of the cloud, tracing the birth of stars, and studying the chemistry of the dust. Some of the most famous dark clouds are visible from Earth. The Horsehead Nebula in Orion, the Coal Sack in the Southern Cross, the dark river that winds through the Milky Way's center. Each is a region where dust blocks the starlight, creating shapes and patterns that have inspired wonder for generations. But dust is not just a veil, it is also a mirror. When starlight strikes a dust grain, some of the light is scattered, creating a soft blue glow known as a reflection nebula. The Pleiades, a cluster of young stars, is surrounded by such a nebula, its stars wrapped in a delicate haze of scattered light. Dust also reddens the light of distant stars, filtering out the blue and letting the red pass through. This effect, called interstellar reddening, makes the Milky Way's core appear redder and dimmer than it truly is. By measuring this reddening, astronomers can map the distribution of dust, revealing the hidden structure of the galaxy. But dust is not just a barrier, it is a bridge. It connects the life cycles of stars, carrying the ashes of the dead to the cradles of the newborn. It is the raw material for planets, moons, comets, and asteroids. It is the canvas on which the galaxy paints its most beautiful and mysterious scenes. As you drift through the dark clouds, you begin to sense their importance. They are not obstacles to be overcome, but mysteries to be embraced. They are the places where the galaxy renews itself, where the old is transformed into the new, where the invisible becomes visible. You realize that the Milky Way is not just a galaxy of stars, but a galaxy of dust and darkness, of shadows and light. It is a place of contrasts, of hidden depths, of secrets waiting to be discovered. You think about the journey of a single dust grain, born in the heart of a dying star, blown into space, drifting for millions of years, joining a cloud, helping to form a new star, a new planet, a new story. You realize that you, too, are made of dust. Your bones, your blood, your breath, all forged in the fires of ancient suns. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of humility, a sense of wonder, a sense of connection. You are a traveler in a galaxy that is both bright and dark, both known and unknown, both home and frontier. Take another breath. Let the dust and darkness fill you with awe. Let the silence of the clouds remind you that every mystery is an invitation, every shadow a promise of discovery. You are a traveler in the Milky Way, drifting through the veils of dust and darkness, seeking the secrets of the galaxy. As you drift away from the crowded heart of the Milky Way, the galaxy opens up before you. The light softens, the stars grow less dense, and the spiral arms begin to reveal their secrets. These arms, winding gracefully through the disk, are not just patterns of light. They are the cradles of creation, the places where new stars are born. Imagine gliding along one of these spiral arms, following its gentle curve through the galaxy. The arm is not a solid structure, but a wave, a region where gravity compresses gas and dust, triggering bursts of star formation. As you move, you pass through clouds of gas, dark and cold, hiding their treasures from view. These are the giant molecular clouds, the nurseries of the Milky Way. Inside these clouds, the story of a star begins. The gas is mostly hydrogen, the simplest and most abundant element in the universe. For millions of years, the cloud drifts through the spiral arm, undisturbed. But then, something changes. A shockwave from a nearby supernova, a collision with another cloud, or the gentle squeeze of the spiral arm itself. The gas begins to collapse, pulled inward by gravity, growing denser and hotter at the center. As the cloud collapses, it fragments into smaller clumps, each one destined to become a star. In the heart of each clump, the pressure and temperature rise until, at last, nuclear fusion ignites. A new star is born, shining with the light of creation, pushing back the darkness, sending energy out into the galaxy. But the birth of a star is not a quiet event. The young star is surrounded by a disk of gas and dust, spinning rapidly, glowing in the infrared. Jets of material shoot out from the poles, carving holes in the cloud, lighting up the gas in brilliant colors. The energy from the star heats the surrounding dust, causing it to glow, creating a cocoon of light that can be seen across the galaxy. As the star grows, it begins to clear away the gas and dust around it. The disk may fragment, forming planets, moons, and asteroids. The jets slow, the cocoon fades, and the star emerges into the galaxy, ready to begin its long journey through the spiral arm. Some regions of the spiral arms are especially rich in star formation. These are the H2 regions, vast clouds of ionized hydrogen lit up by the ultraviolet light of young massive stars. The Orion Nebula, visible from Earth as a faint patch in the Sword of Orion, is one such region. A stellar nursery just 1/300 light-years away, where hundreds of new stars are being born. Other star-forming regions are hidden from view, shrouded in dust that blocks visible light. But with infrared and radio telescopes, astronomers can peer into these dark clouds, watching the process of creation unfold. They see the cold gas collapsing, the disks spinning, the jets firing, the stars igniting. They see the galaxy renewing itself, one star at a time. The spiral arms are not just places of birth, they are also places of youth. The stars that form here are hot and bright, burning with a blue-white light. They live fast and die young, exploding as supernovae after just a few million years. Their deaths send shockwaves through the arm, triggering new waves of star formation, continuing the cycle of creation and destruction. Between the arms, the stars are older, cooler, and redder. They have drifted away from their birthplaces, settling, into quieter orbits, living out their long lives in peace. Some will become red giants, swelling and cooling as they run out of fuel. Others will end their lives as white dwarfs, neutron stars, or black holes, their ashes scattered to seed new generations. As you drift through the spiral arms, you begin to sense the rhythm of the galaxy. It is a place of cycles, of birth and death, of creation and loss, of energy and silence. The arms wind and unwind, the stars form and fade, the gas clouds drift and collapse. Everything is in motion, everything is connected. You realize that the spiral arms are not just features of the galaxy, they are its lifeblood, its engines of renewal. Without them, the Milky Way would be a dark, quiet place, filled with old stars and cold dust. But with them, the galaxy is alive, vibrant, ever-changing. You think about the journey of your own sun, born in a cloud like these, billions of years ago. You imagine the planets forming, the comets and asteroids swirling, the Earth cooling and life beginning. You realize that you are part of this story, a child of the spiral arms, a product of the galaxy's endless creativity. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of gratitude, a sense of wonder, a sense of belonging. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and frontier. Take another breath. Let the spiral arms and star nurseries fill you with awe. Let the light of newborn stars remind you that every ending is a beginning, every darkness a prelude to creation. You are a traveler in the Milky Way, drifting through the spiral arms, witnessing the birth of stars. As you drift deeper into the Milky Way, the stars grow denser, the light grows brighter, and the mysteries grow deeper. You are approaching the galactic center, a place so crowded, so energetic, and so shrouded in dust that for centuries, its true nature was hidden from human eyes. Tonight, let's journey together into the heart of our galaxy and discover what lies at its core. Imagine traveling inward, past the familiar constellations, past the spiral arms, toward the very middle of the Milky Way. The number of stars increases with every light year. The sky becomes a tapestry of light, so thick with suns that darkness seems to vanish. Here, in the central bulge, stars are packed 1,000,000 times more densely than in our quiet corner of the galaxy. If you stood on a planet near the center, your night sky would never be truly dark. Everywhere you looked, you would see the glow of countless stars. But as you approach the center, something strange happens. The light dims, not because there are fewer stars, but because you are looking through thick clouds of gas and dust. These clouds absorb and scatter visible light, hiding the galactic center from view. For centuries, astronomers could only guess what lay beyond this veil. It wasn't until the 20th century, with the invention of radio and infrared telescopes, that we began to peer through the dust. What we found was astonishing. At the very heart of the Milky Way, 26,000 light-years from Earth, lies a region of intense activity, a maelstrom of stars, gas, and mysterious forces. This region is called Sagittarius A, pronounced A star. And at its very center is something even more extraordinary, a supermassive black hole, millions of times the mass of the Sun. This black hole is invisible, but its presence is revealed by the motion of stars and gas swirling around it at incredible speeds. Some stars complete an orbit in just a few years, moving so fast that only an immense, compact object could hold them in its grip. The black hole itself is a place where gravity is so strong that nothing, not even light, can escape. Its event horizon is only about 25 million kilometers across, smaller than the orbit of Mercury, but its mass is more than 4 million times that of the Sun. Around it, a disk of hot gas glows in X-rays and radio waves as matter spirals inward and vanishes into the darkness. But the galactic center is not just a black hole. It is a crowded, chaotic region filled with young, massive stars, dense clusters, and clouds of gas. Some of these stars are among the most massive and luminous in the galaxy, burning brightly and living fast. Others are old and red, survivors from the earliest days of the Milky Way. There are also strange objects, pulsars, magnetars, and mysterious radio sources that flicker and flare. Some of these may be the remnants of supernovae, the collapsed cores of stars that exploded long ago. Others are still unexplained, their signals hinting at new physics, or at least new stories waiting to be told. The galactic center is a place of extremes. Temperatures soar to millions of degrees. Magnetic fields twist and snap. Shockwaves from exploding stars ripple through the gas, triggering new waves of star formation. It is a place of birth and death, of creation and destruction, of energy and silence. And yet, for all its violence, the galactic center is also a place of beauty. Infrared images reveal clusters of stars shining through the dust, their light painting the clouds in shades of red and gold. Radio telescopes map the swirling gas, tracing the spiral arms as they wind into the core. X-ray observatories capture the flares and bursts from the black hole, brief flashes of energy that travel across the galaxy. You realize as you drift near the center that you are witnessing the beating heart of the Milky Way. The black hole at the core is not a monster, but a quiet anchor holding the galaxy together with its gravity. The stars and gas that swirl around it are part of a cosmic dance, a cycle of creation and loss that has played out for billions of years. You think about the journey of light from the galactic center, how it travels for 26,000 years to reach Earth, passing through clouds of dust, through the spiral arms, through the thin veil of our own atmosphere. By the time it reaches your eyes, it is ancient, a message from the deep past, a whisper from the heart of the galaxy. You wonder what secrets are still hidden in the center. Are there more black holes, smaller but still powerful, waiting to be discovered? Are there planets orbiting the crowded stars? Worlds where night is never dark? Are there civilizations watching the same sky, asking the same questions? As you float in the glow of the galactic center, you feel a sense of awe, a sense of humility, a sense of connection. You are a traveler in a galaxy that is both familiar and strange, both home and frontier. You are part of a story that began long before you and will continue long after. Take another breath. Let the mysteries of the galactic center fill you with wonder. Let the ancient light remind you that even in the darkest places there is beauty, there is energy, there is life. You are a traveler at the heart of the Milky Way, a witness to its hidden heart of darkness. As you drift through the spiral arms of the Milky Way, you begin to wonder, are we alone? Is Earth the only world where life has blossomed, or are there other oases scattered among the stars? The search for life is one of the greatest mysteries of the galaxy, a quest that stretches from the planets of our own solar system to the farthest reaches of the Milky Way. Let's begin close to home. Our sun is just one of more than 200 billion stars in the Milky Way. Around it, 8 planets circle, each with its own story, its own climate, its own possibilities. Earth is the only planet we know of that harbors life, but Mars, Europa, Enceladus, and Titan all show hints of water, chemistry, and perhaps, in their hidden oceans or ancient past, the potential for life. But what about the rest of the galaxy? In the last few decades, astronomers have discovered thousands of exoplanets, planets orbiting other stars. Some are hot Jupiters, gas giants orbiting close to their suns. Others are super-Earths, rocky worlds larger than our own. Some orbit in the habitable zone, the region around a star where temperatures are just right for liquid water to exist. The habitable zone is sometimes called the Goldilocks zone. Not too hot, not too cold, but just right. But even this is only part of the story. A planet's atmosphere, its chemistry, its history, and its relationship with its star all play a role in determining whether it can support life. As you drift through the galaxy, you realize that the Milky Way is full of potential. There may be billions of habitable worlds, planets with oceans, continents, clouds, and perhaps even life. Some may be covered in forests and jungles, others in ice and snow, others in deserts and mountains. Some may be home to simple microbes, others to complex ecosystems, and perhaps somewhere to intelligent beings looking up at their own night sky, wondering if they are alone. But the search for life is not just about planets, it is also about place. The Milky Way is not uniform. It has regions that are more or less hospitable to life. Astronomers call this the galactic habitable zone, a region of the galaxy where conditions are most favorable for life to arise and survive. The galactic habitable zone is shaped by many factors. Too close to the center of the galaxy, and the environment is dangerous. Supernovae, gamma-ray bursts, and the intense gravity of the central black hole can sterilize planets and strip away atmospheres. Too far from the center, and there may not be enough heavy elements to form rocky planets or complex chemistry. Our solar system is located in a relatively quiet, safe region of the galaxy, far enough from the center to avoid most hazards, but close enough to have the elements needed for life. This may not be a coincidence. Life, it seems, thrives in the middle ground, where conditions are stable, resources are plentiful, and time is on its side. But even within the habitable zone, life is not guaranteed. Planets must survive the violence of star birth, the chaos of planetary migration, the bombardment of comets and asteroids. They must hold on to their atmospheres, maintain liquid water, and avoid catastrophic events. Life is resilient, but it is also fragile, and the odds of all the right conditions coming together may be slim. Still, the galaxy is vast, and time is long. Even if life is rare, the sheer number of stars and planets means that it may be common in the Milky Way. Some scientists estimate that there could be thousands, even millions of civilizations in our galaxy alone. Others are more cautious, pointing out the many challenges and uncertainties. The search for life is not just a scientific quest, it is a journey of imagination, of hope, of wonder. We listen for signals from distant stars. We scan the skies for signs of technology. We send probes to the planets and moons of our own solar system. We dream of finding a second Earth, a twin to our own world, a place where life has taken a different path. You realize, as you drift through the Milky Way, that the search for life is also a search for connection. We want to know that we are not alone, that the universe is not empty, that our story is part of a larger tapestry. We want to find companions, to share our questions, our dreams, our wonder. You think about the possibilities, about the worlds that may exist, the life that may thrive, the civilizations that may rise and fall, all hidden among the stars. You imagine the messages that may be traveling through the galaxy, the signals that may one day reach us, the discoveries that may change our understanding of life and the universe. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of hope, a sense of curiosity, a sense of belonging. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and full of possibilities. Take another breath. Let the search for life fill you with wonder. Let the habitable worlds and the galactic habitable zone remind you that every question is an invitation, every journey a chance to discover something new. You are a traveler in the Milky Way, drifting among the worlds that may harbor life, seeking the secrets of the galaxy's living heart. As you drift through the outskirts of the Milky Way, you begin to sense that the galaxy's story is not one of quiet isolation, but of encounters, collisions, and cosmic change. The Milky Way, for all its beauty and apparent calm, is a survivor of violence, a galaxy shaped by ancient mergers, ongoing interactions, and a dramatic future yet to unfold. Imagine, for a moment, the galaxy not as a static spiral, but as a living, moving system. Every star, every cloud, every cluster is in motion, orbiting the center, pulled by gravity, nudged by neighbors. Over billions of years, these motions bring galaxies together, sometimes gently, sometimes with spectacular force. The Milky Way's history is written in the stars and streams that surround it. The stellar streams you saw in the halo are the remnants of smaller galaxies that were torn apart and absorbed by our own. Each stream is a trail of stars, a fossil record of a cosmic collision. By mapping these streams, astronomers can reconstruct the Milky Way's past, uncovering the story of how it grew by devouring its neighbors. Some of these mergers were ancient, their remnants now fully mixed into the halo. Others are ongoing. The Sagittarius dwarf galaxy is currently being shredded by the Milky Way's gravity, its stars stretched into a long looping stream that wraps around the galaxy. The Magellanic Clouds are also interacting with the Milky Way, their gas and stars being pulled out into the Magellanic Stream. But the most dramatic collision is yet to come. In about 4 billion years, the Milky Way will meet its match. The Andromeda Galaxy, our nearest large neighbor, is on a collision course with us. Both galaxies are moving toward each other at hundreds of kilometers per second, drawn together by their mutual gravity. When they collide, it will not be a sudden crash, but a slow, majestic dance. The galaxies will pass through each other, their stars rarely colliding directly, but their gas clouds will interact, triggering waves of star formation. Over the course of 1 billion years, the two galaxies will merge, their spiral arms tangled. Their cores drawn together, their stars scattered into new orbits. The result will be a new, larger galaxy, sometimes called Milkomeda or Milkdromeda, an elliptical galaxy with a new structure, a new history, a new future. The Sun, if it survives, will find itself in a new orbit, perhaps farther from the center, perhaps closer. The night sky will be transformed, filled with the light of new stars, new clusters, new nebulae. But even before this grand merger, the Milky Way is constantly shaped by smaller collisions. Dwarf galaxies are being accreted, their stars added to the halo, their gas fueling new generations of stars. Globular clusters are captured, their orbits altered, their stars mixed into the galaxy's population. These collisions are not just destructive, they are creative. The energy and turbulence of a merger can trigger bursts of star formation, lighting up the galaxy with new stars, new planets, new possibilities. The heavy elements forged in these stars enrich the galaxy, making it more hospitable to life. You realize as you drift through the Milky Way that the galaxy is not a finished product, but a work in progress. It is shaped by its past, but always changing, always evolving. Every collision, every merger, every encounter leaves its mark, adding to the richness and complexity of the galaxy. You think about the future, about the night sky billions of years from now, when the Milky Way and Andromeda have merged, when the stars of both galaxies are mixed together, when new worlds have formed from the debris of the collision. You imagine the stories that will be told by future travelers, the questions they will ask, the mysteries they will seek to solve. You also think about the resilience of the galaxy. For all its violence, the Milky Way endures. Its stars survive, its planets persist, its story continues. The collisions that shape it are not the end, but the beginning of new chapters, new cycles, new dreams. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of awe, a sense of humility, a sense of connection. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and part of a larger universe. Take another breath. Let the story of galactic collisions fill you with wonder. Let the dance of the galaxies remind you that every ending is a beginning, every encounter a chance for creation, every journey a step in the endless evolution of the cosmos. You are a traveler in the Milky Way, drifting through the aftermath of ancient collisions, awaiting the grand merger yet to come. As you float in the quiet outskirts of the Milky Way, you begin to notice that our galaxy is not alone. All around, faint companions drift through the darkness. Small, ancient galaxies that orbit the Milky Way like dancers circling a grand stage. These are the dwarf galaxies, the satellites of our home, each with its own story, its own mysteries, its own place in the cosmic dance. Imagine looking out from the edge of the Milky Way's halo. The main disk of the galaxy glows in the distance, a spiral of light and dust. But scattered across the sky, you see dozens of smaller galaxies, some bright and close, others faint and far, their stars barely visible against the black. These are the Milky Way's satellites, bound to us by gravity, moving in great, looping orbits that can take billions of years to complete. The most famous of these companions are the Large and Small Magellanic Clouds, 2, irregular dwarf galaxies visible to the naked eye from the southern hemisphere. The Large Magellanic Cloud, or LMC, is about 160,000 light-years away, while the Small Magellanic Cloud, or SMC, is a bit farther, at 200,000 light-years. Both are rich in gas and dust, and both are sites of active star formation, with bright nebulae and young star clusters lighting up their interiors. The Magellanic Clouds are not just passive companions. They are interacting with each other and with the Milky Way, their mutual gravity pulling out long streams of gas and stars. The Magellanic Stream, a ribbon of hydrogen gas stretching across the sky, is a testament to this ongoing interaction, a sign that galaxies are not isolated but connected, their stories intertwined. Beyond the Magellanic Clouds, the Milky Way is orbited by dozens of smaller dwarf galaxies. Some, like the Sagittarius dwarf spheroidal galaxy, are so close that they are being torn apart by our galaxy's gravity. Their stars stretched into long streams that wrap around the Milky Way. Others, like the Fornax and Sculptor dwarfs, are more distant, quietly circling in the dark. These dwarf galaxies come in many shapes and sizes. Some are spheroidal, round, faint, and lacking in gas, their stars old and metal poor. Others are irregular, with knots of star formation and clouds of gas. Some are so faint and diffuse that they were only discovered in the last few decades, their stars barely distinguishable from the background. Dwarf galaxies are important for many reasons. They are the most common type of galaxy in the universe, and they are thought to be the building blocks from which larger galaxies like the Milky Way formed. By studying their stars, astronomers can learn about the early history of the universe, the processes of galaxy formation, and the mysterious nature of dark matter. Some dwarf galaxies are being cannibalized by the Milky Way, their stars and gas stripped away and added to our own. This process of galactic accretion is ongoing, over billions of years. The Milky Way has grown by devouring its smaller neighbors, their remnants now scattered through the halo as streams and clusters. But not all interactions are destructive. Some dwarf galaxies pass by at a safe distance, their orbits stable for billions of years. Others may one day merge with the Milky Way, adding their stars to our own, their stories becoming part of the larger narrative of the galaxy. You realize, as you drift among the satellites, that the Milky Way is not a solitary island, but a community, a gathering of galaxies, each with its own history, its own path, its own destiny. The dance of the dwarfs is slow and graceful, measured in millions and billions of years, but it is always changing, always evolving. You think about the stars in these dwarf galaxies, some as old as the universe itself, others newly born in clouds of gas. You imagine the planets that might orbit these stars, the possibilities for life, the stories that might unfold in worlds far from our own. You also think about the future. In a few billion years, the Milky Way will collide with the Andromeda Galaxy, our nearest large neighbor. The dwarf galaxies that orbit both giants will be swept up in the merger, their stars scattered, their identities lost in the new, larger galaxy that will emerge. The dance of the dwarfs is part of a larger choreography, a cosmic ballet that spans the ages. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of wonder, a sense of connection, a sense of humility. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and part of a larger universe. Take another breath. Let the silence of the satellites fill you with awe. Let the dance of the dwarf galaxies remind you that every journey is shared, every orbit a story, every companion a piece of the cosmic puzzle. You are a traveler in the Milky Way, drifting among the dancing dwarfs, seeking the secrets of the galaxy's companions. As you drift farther from the bright spiral arms and the crowded heart of the Milky Way, the galaxy begins to thin out. The stars grow sparser, the light grows dimmer, and the familiar patterns of the disk give way to a vast, mysterious realm, the galactic halo and the outskirts, where the oldest and most elusive inhabitants of our galaxy reside. Imagine gliding upward, away from the flat plane of the Milky Way's disk. The spiral arms fade beneath you, and the galaxy's bright band becomes a thin, glowing ribbon. Above and below, the darkness stretches on, but it is not empty. Here, in the halo, you find the ghosts of the galaxy, ancient stars, globular clusters, and the invisible presence of dark matter. The galactic halo is a vast spherical region that surrounds the Milky Way's disk and bulge. It extends for hundreds of thousands of light years, far beyond the visible edge of the galaxy. The halo is faint and diffuse, its stars scattered across immense distances. Most of these stars are old, some more than 12 billion years old, among the first to form in the galaxy's youth. Within the halo, you find globular clusters, tight balls of hundreds of thousands, sometimes millions, of stars bound together by gravity. These clusters are among the oldest structures in the galaxy, relics from a time when the Milky Way was still forming. They orbit the galactic center in great looping paths, passing through the disk and out into the dark, like cosmic lanterns lighting the way. The stars in the halo are different from those in the disk. They are metal poor, meaning they contain fewer heavy elements than younger stars. This is a clue to their age. They formed before the galaxy was enriched by generations of supernovae. Their orbits are tilted and elongated, moving through the galaxy in all directions, not just around the center. But the halo is not just a collection of old stars. It is also home to dark matter, an invisible substance that outweighs all the stars and gas in the galaxy combined. We cannot see dark matter, but we know it is there by its gravitational pull. It holds the galaxy together, shapes its rotation, and binds it to its neighbors. Without dark matter, the Milky Way would fly apart, its stars flung into the void. Farther out, beyond the halo, lie the outskirts of the galaxy, a realm of faint, diffuse light, where the Milky Way blends into the intergalactic medium. Here, you find streams of stars, the remnants of smaller galaxies that were torn apart and absorbed by the Milky Way's gravity. These stellar streams are the footprints of ancient mergers, tracing the history of the galaxy's growth. Some of these streams are still visible, winding through the halo like rivers of light. Others have faded into the background, their stars scattered across the sky. By mapping these streams, astronomers can reconstruct the Milky Way's past, uncovering the story of how it grew by devouring its neighbors. The outskirts are also home to dwarf galaxies, small faint companions that orbit the Milky Way at great distances. Some are being torn apart by tidal forces, their stars stripped away and added to the halo. Others remain intact, drifting through the dark, their own stories unfolding in parallel to ours. As you drift through the halo and the outskirts, you begin to sense the scale of the galaxy. The Milky Way is not just a flat disk of stars, but a layered, textured, dynamic system. It is a place of order and chaos, of creation and destruction, of beauty and mystery. You realize that the halo is a bridge between the galaxy and the universe beyond. It is a place where the Milky Way meets the cosmos, where the boundaries blur, where the past and future of the galaxy are written in the motions of stars and the pull of gravity. You think about the journey of a single star in the halo, born in a globular cluster orbiting the galaxy for billions of years, passing through the disk out into the dark and back again. You imagine the mergers and collisions that shape the halo, the streams of stars that trace the galaxy's history, the invisible web of dark matter that holds it all together. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of awe, a sense of humility, a sense of connection. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and frontier. Take another breath. Let the silence of the halo fill you with wonder. Let the darkness remind you that every edge is a beginning, every ghost a story, every journey a chance to discover something new. You are a traveler in the Milky Way, drifting through the halo and the outskirts, seeking the secrets of the galaxy's ghosts. As your journey through the Milky Way draws to a close, you find yourself drifting in a quiet space between memory and possibility. The stars shine above, the ancient dust lies beneath, and the long arc of your voyage circles back to where it began. With a question, a sense of wonder, and the gentle hush of the night. What have you learned? Riding through the galaxy, what gifts does the Milky Way offer to those who listen, who dream, who dare to imagine themselves as part of its story? You have learned about scale. The Milky Way is vast beyond comprehension, 100,000 light-years across, home to hundreds of billions of stars, each with its own planets, its own history, its own possibilities. You realize that you are small, a single mind on a single world, but you are also part of something immense, something ancient, something beautiful. You have learned about connection. The atoms in your body were forged in the hearts of stars, scattered by supernovae, gathered into clouds, woven into planets, and now, for a brief moment, into you. You are the universe, becoming aware of itself, looking back at its own history, dreaming of its own future. Every star, every planet, every grain of dust is part of the same story, the same dance, the same web of existence. You have learned about change. The Milky Way is not a static place, but a living, evolving system. Stars are born, live, and die. Galaxies collide and merge. Planets form and are destroyed. Life arises, flourishes, and fades. The only constant is transformation. The only certainty is surprise. The galaxy is a reminder that nothing lasts forever, but everything is part of a larger cycle, a larger story. You have learned about mystery. For all we know, there is so much more we do not. Dark matter, dark energy, the origins of life, the fate of the universe. These are questions that remain, puzzles that invite us to look deeper, to listen more carefully, to wonder more boldly. The Milky Way is a teacher, always reminding us that the journey is not over, that the adventure continues, that the unknown is not to be feared, but embraced. You have learned about imagination. The Milky Way is not just a place, but a canvas for the mind, a source of stories, symbols, and dreams. It is a river of light, a path for souls, a bridge between worlds. It is a reminder that science and art, fact and story, are not enemies, but companions. Two ways of exploring, two ways of understanding, two ways of being human. You have learned about hope. The search for life, the quest for understanding, the longing for connection. These are not just scientific pursuits, but human ones. They are expressions of our deepest desires, our highest aspirations, our most enduring dreams. The Milky Way is a symbol of what is possible, of what is yet to come, of the future we can build together. As you prepare to return to your own world, you take one last look around. The galaxy is quiet now, the spiral arms winding through the dark, the halo stretching into the void, the satellites circling in their slow dance. The stars shine with a steady light, and the silence is deep and gentle. You feel gratitude for the journey, for the lessons, for the chance to be a traveler among the wonders of the cosmos. You return, slowly, to your own life. The bed, the chair, the familiar sounds of night. But something has changed. You carry with you the patience of the stars, the resilience of dust, the wonder of the spiral arms. You know that, in some small way, you are connected to the great cycles of the universe, to the comets that wander, the planets that spin, the stories that unfold in the darkness. You are a traveler, always. Whether riding a comet or walking beneath the sky, you are part of a journey that has no end, a journey of discovery, of transformation, of quiet awe. So as you drift towards sleep, let the lessons of the Milky Way settle gently in your mind. Let the silence of space become the silence of rest. Let the wonder of the cosmos become the wonder of your dreams. You are a traveler in the Milky Way, drifting through the river of stars, carried by the beauty, the mystery, and the endless possibility of the universe. Good night, fellow traveler. May your journey be gentle, your dreams be bright, and your heart always open to wonder. As you drift beneath the stars, you realize that the Milky Way is not just a physical place, not just a collection of stars and dust and dark matter. It is also a canvas for the human mind, a source of stories, symbols, and dreams. For as long as people have looked up at the night sky, the Milky Way has inspired wonder, fear, hope, and creativity. Tonight, let's explore the galaxy not only as scientists, but as storytellers, artists, and dreamers. Imagine yourself thousands of years ago, before city lights, before telescopes, before science as we know it. The night sky is vast and dark, and the Milky Way arches overhead, a glowing river of light, mysterious and beautiful. What is it? Where does it come from? What does it mean? In ancient Greece, the Milky Way was said to be the milk of Hera, spilled across the sky as she nursed the infant Heracles. The word galaxy itself comes from the Greek galaxias, meaning milky. The Romans saw it as a road of milk, a celestial pathway for the gods. In other cultures, the Milky Way was a river, a path for souls, a bridge between worlds, a road for spirits and ancestors. The Maya called it the White Road, a celestial highway that connected the earth to the heavens. In Australia, Aboriginal peoples saw it as a river of dust, the track of a great emu, or the smoke from ancient campfires. In Africa, the Khoisan people imagined the Milky Way as the ashes of a campfire, scattered by a girl who wanted to light the way for travelers. In China, it was the Silver River, separating two lovers, the weaver girl and the cowherd, who could meet only once a year when magpies formed a bridge across the sky. In North America, the Lakota called it the Spotted Road, a path for spirits to travel to the afterlife. The Cherokee saw it as a trail of cornmeal, spilled by a dog fleeing from a village. The Inuit imagined it as the trail of a giant fish swimming through the sky. The Milky Way has also inspired art and poetry. In the Renaissance, painters depicted it as a swirling band of light, a symbol of the infinite, the mysterious, the divine. Poets wrote of its beauty, its mystery, its power to evoke longing and awe. Dante, in his Divine Comedy, described the Milky Way as a white path in the sky, a symbol of the journey of the soul. In modern times, the Milky Way has become a symbol of the universe itself, a reminder of our place in the cosmos, our connection to the stars, our longing to explore and understand. It appears in science fiction as the setting for epic journeys, in music as a metaphor for love and distance, in film as a backdrop for adventure and discovery. But the Milky Way is not just a symbol for others. It is a personal experience, a memory, a dream. Perhaps you remember seeing it for the first time, far from city lights, its glow stretching from horizon to horizon. Perhaps you have wished upon its stars, wondered about its secrets, felt a sense of peace and belonging beneath its light. You realize as you drift through the galaxy that the Milky Way is both real and imagined, both fact and story, both science and art. It is a place of atoms and gravity, but also of meaning and mystery. It is a reminder that the universe is not just out there, but also within us, in our minds, our hearts, our dreams. You think about the power of imagination, the ability to see patterns in the stars, to tell stories about the sky, to find meaning in the darkness. You realize that science and myth are not enemies, but companions. Two ways of exploring, two ways of understanding, two ways of being human. You also think about the future. What new stories will we tell about the Milky Way? What new art will we create? What new dreams will we dream as we explore the galaxy, as we learn its secrets, as we become part of its story? As you prepare to reflect on all you have learned, you feel a sense of gratitude, a sense of wonder, a sense of connection. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and inspiration. Take another breath. Let the myths and art of the Milky Way fill you with awe. Let the stories remind you that every question is a poem, every discovery a painting, every journey a dream. You are a traveler in the Milky Way, drifting through the river of stars, carried by the imagination of humanity. As you drift through the Milky Way, you begin to sense that there is more to the galaxy than meets the eye. The stars, the gas, the dust. These are only the visible threads in a much larger tapestry. Beneath and beyond the light, something unseen shapes the galaxy's structure, holds it together, and binds it to the universe. This is dark matter, the invisible web that weaves through the cosmos, a mystery as profound as any in science. Let's begin with a simple question. Why doesn't the Milky Way fly apart? The stars in the outer regions of the galaxy orbit the center at speeds that, by all rights, should send them spinning off into space. Yet they remain bound, circling the core in orderly paths. The visible mass of the galaxy, stars, gas, dust, is not enough to account for this. Something else, something unseen, must be providing the extra gravity. This is where dark matter comes in. Astronomers first suspected its existence in the 1930s, when they noticed that galaxies and clusters moved too quickly to be held together by their visible mass. Later, in the 1970s, Vera Rubin and others measured the rotation curves of spiral galaxies and found that the outer stars moved just as fast as those closer in, defying the predictions of Newtonian physics unless there was a vast amount of unseen mass. Today, we know that dark matter makes up about 85% of the mass of the universe. In the Milky Way, it forms a vast spherical halo that extends far beyond the visible disk. This halo is invisible. It does not emit, absorb, or reflect light, but its gravitational pull is unmistakable. It shapes the orbits of stars, the paths of galaxies, the structure of the cosmic web. But what is dark matter? That is the great mystery. It is not made of ordinary atoms, the protons, neutrons, and electrons that make up stars, planets, and people. It does not interact with light or with itself, except through gravity. It passes through the galaxy, through the Earth, through you, without leaving a trace. Scientists have proposed many candidates for dark matter. Some think it is made of WIMPs, weakly interacting massive particles, hypothetical particles that interact only through gravity and the weak nuclear force. Others suggest axions, tiny, lightweight particles that could fill the universe like a sea. Still others propose sterile neutrinos, primordial black holes, or other exotic forms of matter. Experiments around the world are searching for dark matter. Deep underground, detectors wait for the faintest hint of a collision between a dark matter particle and an ordinary atom. In space, telescopes look for the subtle effects of dark matter on the cosmic microwave background, on the distribution of galaxies, on the bending of light by gravity. So far, the search has found only hints, only questions, only the promise of discovery. But even without knowing what dark matter is, we can see its effects. It holds the Milky Way together, keeps the stars in their orbits, binds the galaxy to its neighbors. It shapes the large-scale structure of the universe, forming a cosmic web of filaments and nodes. With galaxies and clusters gathering at the intersections, you realize, as you drift through the Milky Way, that you are moving through a sea of dark matter. Every star, every planet, every atom is embedded in this invisible web. The galaxy is not just a collection of stars, but a structure shaped by forces we cannot see, by matter we cannot touch, by mysteries we have only begun to explore. You think about the implications. If dark matter were to vanish, the galaxy would unravel, the stars would scatter, the universe would be a very different place. Dark matter is the silent architect of the cosmos, the hidden hand that shapes the fate of galaxies, the destiny of stars, the possibility of life. You also think about the nature of mystery. Dark matter is a reminder that the universe is not fully known, that there are still secrets waiting to be uncovered, that science is a journey, not a destination. Every question leads to new questions, every discovery to new mysteries, every answer to new wonder. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of awe, a sense of humility, a sense of curiosity. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and full of the unknown. Take another breath. Let the presence of dark matter fill you with wonder. Let the invisible web remind you that every silence is full of meaning, every darkness full of structure, every mystery full of promise. You are a traveler in the Milky Way, drifting through the unseen, seeking the secrets of the galaxy's hidden heart. As you drift through the Milky Way, you begin to notice that the galaxy is not silent. It hums, it pulses, it whispers with signals that travel across the darkness, some regular and predictable, others sudden and mysterious. These are the messages of the cosmos, the echoes of strange objects and unknown events, the signals from the dark. Let's begin with the most regular of these cosmic beacons, pulsars. Pulsars are the spinning remnants of massive stars, neutron stars that emit beams of radio waves from their magnetic poles. As they spin, these beams sweep across space like the light from a lighthouse. If Earth happens to lie in the path of a beam, we detect a pulse of radio waves perfectly timed, repeating with every rotation. Some pulsars spin hundreds of times per second, their pulses so regular that they rival the best atomic clocks on Earth. Astronomers use them to study the galaxy, to test the laws of physics, even to navigate spacecraft. The first pulsar was discovered in 1967, its signal so precise that it was briefly nicknamed LGM-1, for Little Green Men, before its true nature was understood. But not all signals from the galaxy are so regular. In recent years, astronomers have discovered a new kind of cosmic mystery, fast radio bursts, or FRBs. These are brief, intense flashes of radio waves, lasting just a few milliseconds but releasing as much energy as the sun does in a day. Most FRBs come from far outside the Milky Way, but some have been traced to sources within our own galaxy. The origins of FRBs are still unknown. Some repeat, others are one-time events. They may be caused by magnetars, by collisions of neutron stars, or by something even stranger. Each new burst is a puzzle, a clue, a question waiting to be answered. Some scientists have even speculated, though with caution, that FRBs could be signals from advanced civilizations, using powerful transmitters to send messages across the cosmos. The galaxy is full of other signals too. X-ray binaries, systems where a neutron star or black hole pulls material from a companion star, emit regular pulses of X-rays as the material spirals inward. Gamma-ray bursts, the most energetic explosions in the universe, send out brief flashes of high-energy light, sometimes from the deaths of massive stars, sometimes from the mergers of neutron stars. There are also signals that defy explanation. Mysterious radio sources that flicker and fade, objects that emit bursts of energy and then go silent, patterns that repeat and then vanish. Some of these may be new kinds of stars, new kinds of explosions, or new kinds of physics. Others may be artifacts, illusions, or the echoes of processes we do not yet understand. Astronomers use giant radio telescopes to listen to the galaxy, scanning the sky for signals, mapping the sources, searching for patterns. The Arecibo Observatory in Puerto Rico, the Parkes Observatory in Australia, the Very Large Array in New Mexico. All have played a role in uncovering the galaxy's hidden messages. But the search is not just for natural signals. For decades, scientists have listened for signs of intelligence, messages from other civilizations, signals that might say, "We are here." The search for extraterrestrial intelligence, SETI, uses radio telescopes to scan the sky, looking for patterns that cannot be explained by nature alone. So far, the search has found only silence, but the quest continues, driven by hope, curiosity, and wonder. You realize as you drift through the Milky Way that the galaxy is alive with signals. Some are regular, some are random, some are mysterious. Each one is a story, a clue, a piece of the puzzle. The signals from the dark are the heartbeat of the galaxy, the whispers of its hidden heart. You think about the possibilities, about the objects that send these signals, the processes that create them, the mysteries that remain. You imagine the discoveries yet to come, the questions yet to be asked, the answers yet to be found. You also think about the nature of discovery. Every signal is a challenge, an invitation to look deeper, to listen more carefully, to wonder more boldly. The galaxy is not silent, but full of messages, waiting for those who are patient, curious, and open to the unknown. As you prepare to explore the next mysteries of the Milky Way, you feel a sense of excitement, a sense of humility, a sense of connection. You are a traveler in a galaxy that is both ancient and new, both familiar and strange, both home and full of surprises. Take another breath. Let the signals from the dark fill you with awe. Let the pulses, bursts, and whispers remind you that every silence is full of meaning, every darkness full of light, every unknown full of possibility. You are a traveler in the Milky Way, drifting among the signals of the cosmos, seeking the secrets of the galaxy's hidden messages.